Hey everybody, we're going to be looking at perimeter and area on the coordinate plane today. It's section 10.5 for geometry, section 2.5 for math 3. So let's go ahead and get started with this explore. What they're going to ask you to do is plot the different points, and then we'll find the side lengths. So if I look at point A, that's going to go in at -1, 4. B's at 4, 4. C, 3, -2, D, -1, -4, and E, -4, +1. So that is going to make kind of a funky looking pentagon. Pentagon just meaning 5 sides. So how do we find the perimeter? Well, excuse me. You're going to use the distance formula. Now, looking at side AB, that one's pretty easy because it's horizontal. Anything horizontal or vertical, I can just count. So AB is 1, 2, 3, 4. That is 5 units long. The others are all at some sort of diagonal, which means I'm going to need to use the distance formula. So my distance formula, remember, is D equals the square root of, in parentheses, x2 minus x1, and then square that difference, and then do the same thing with your y's. This difference here, x2 minus x1, is the same as a side length if you were to turn it into a triangle. So if I were, for example, on, let's go with BC, the x difference would be that distance. So in that case, it's 1. We're going to do this example for BC. So I could just write 1 squared. And then for the y, it's how far up I went, which would be 1, 2, 3, 4, 5, 6. And I get the square root of 37, which you could plug into your calculator. And let me grab one. And I get, for this one, we're going to plug in and we're going to round to 2 decimals for all of these problems. So BC is 6.08. Let's say I were going to do it for CD, and we'll go ahead and use the actual distance formula for that, and you'll see we get the same, ends up being the same outcome. CD, if I use my coordinates, I'm looking at x -1 minus 3 squared plus -4 minus a -2 squared. Minus a negative becomes plus. For me, I take care of that right away, otherwise I tend to drop negatives. So I'm looking at -4 squared. When you plug that into your calculator, make sure you put the -4 in parentheses, otherwise your calculator will do something funky. And -4 plus 2 becomes -2 squared. I get the square root of 16 plus 4, which is the square root of 20, and that comes out to 4.47. And we can see that our counting method would have worked here as well, because I'm looking at a vertical change of 2 and a horizontal change of 4. The positive negative doesn't matter because we're squaring it. So how do we find the perimeter? We add up all the side lengths. So you would add up the value of AB plus the value of BC plus CD plus DE plus EA, and whatever that gets. So we've found 3 of those. And you would go ahead and find the other 2, and then add them together. So that's how you find your perimeter. let's go ahead and take a look at example 1. So this one is talking about area. Now, depending on the shape, there are different formulas. So you might, I don't know if you want to dog-ear this page or something, or write these some other place. These formulas will be extremely helpful for you for solving all these problems. So to find the area of the figure, we might still need to use the distance formula to find some of these lines. So real quick, B means base, H means height, and that is vertical height, or which is usually in a triangle or anything, it's perpendicular to your base. Notice we've got a right angle. So it's not always a side length. And D stands for diagonal, so that's from one point to the point opposite it. So they've given me these coordinates. And what I'd have to do is find the height. So I've already got a base, and you can pick any side. This example picked side A. So I've got my base, I can find the distance of it. Doing the same thing we did in example 1. They've done it for us. Here, AC is the square root of 90 degrees. The question now becomes, where do I get the height from? Well, remember, it has to be perpendicular. So if I figure out the slope of this line, looks like I've gone up 1, 2, 3, and over 3, 1, 2, 3, 9. So the slope of AC is 1/3. To find the perpendicular, I'm going to flip that over and change the sign. So it's positive, so I'm going to change it to negative. So the slope of the perpendicular line is -3/1. So starting at B, -3 means I go down 1, 2, 3. +1, I go 1 in the right direction, and that gives me the coordinates for that perpendicular height. So that gives me point D. Point D appears to be at -1, -1. Well, now I can use the points B and D. We just found D, and B was given to us. And I can plug those into my formula. So here they've done it in the coordinates. You could also use your counting method like we did up for side CD. Or no, sorry, side BC. Where I look and I see that I have a side length that is 1 unit across and 3 units down. Square both of those, and I get the square root of 10. So, whoops, sorry, I did not mean to scroll like that. Get back where we're at. So they simplified. We're going to talk about simplification next week, so don't worry about doing that simplification for today. We're going to look at just use square root of 90, and that's perfectly fine. So if I type in, or plug into my calculator, I should say, area of a triangle, 1/2 base times height. So I go 1/2 times the square root of 90 times the square root of 10. In my calculator, I get, so 1 divided by 2 times the square root of 90. Make sure if you're using a graphing calculator, you use the over arrow to get out from the square root. The 10 and the 90 need their own square root symbol. That comes out to 15. 15 square units because it is an area. We're going to stop there. And this one is doing the exact same thing, except it's appears to be a rectangle because my slopes are perpendicular. That's a 90-degree angle if I check my slopes. And so to find the area of a rectangle, it's just base times height. You would find the distance of GF using distance formula, and the distance of DG, so that would be your height, your base and your height. Once you find those distances, multiply them together, and that gives you the area of that rectangle. We're going to stop there for today, and I will see you all later.